In this video, we're going to be solving systems of equations by elimination. Now, in the Algebra 1 textbook, I've combined two sections into one because I'm really recording these for the summer school classes. If I've ever used these for my regular Algebra 1 class, we'll just do a lot more practice with this. Okay, so solving by elimination. Multiply at least one equation by constant to get two equations that contain opposite terms. Remember, what does opposite terms mean? Means one positive, one negative. Okay? And then you add the two equations, eliminating one variable. Okay? We solve our equation, and then we go back, plug in, so that we have our answer as an ordered pair. So, looking at this, first example. What you want to make sure you realize is you want to make sure that you realize is you're looking for same coefficient, opposite signs. So just look at this. Do I have one variable in each equation, same coefficient, same number in front with opposite signs? So I do. Those first two equations, the x's, are the same variable 3, but opposite signs. So what I can do is I can just now add these. So negative 3x plus 3x, that goes away. 4y minus 6, I get a negative 2y. I'm just adding. Now I have this equation that I solve. Again, remember, your answer is going to be an ordered pair. So now how do I get my x out? You pick one of the two equations. Pick one of the two equations and plug negative 15 in for y. I'm going to pick the top one. I don't know why I chose the top one. I add 60 over, I divide by negative 3, and we get negative 24. Okay? So this was, I'm going to say, one of the easiest cases. And this is the very first section, okay, where we're just adding, eliminating a variable. That's why this is called elimination. One variable, once we add our equations, is eliminated. Okay, use elimination to solve the system of equations. So just look at this and think, do I have the coefficient, the same number, but opposite signs? We don't. But what we do have is we have the first equation, I'm going to leave as is. I'm going to multiply this by negative 1. So I'm going to multiply this by negative 1. So I get negative 4x plus 3y equals a negative 18. I just realized I have a 2x there. That should be a 28. Now we add those equations. Again, this is called elimination for a reason. Those get eliminated. I now add, and I have 5y. I add 28 and 18. I get 10. I divide by 5. So again, I'm looking for an ordered pair, an x and a y. So I know my y. Plug back into one of the equations to get x. It doesn't matter which one you plug back into. I'm going to choose the top one just because everything is positive. So I have 4x equals 4x plus 4 equals 28. 4x equals 24. I divide by 4 and I get x equal to 6. Now this one's a little bit more complicated. Again, remember what we're trying to do. We're trying to get it so that our coefficients have the same value, but one's positive and one's negative, so that when I add them, they get eliminated. You want to try and avoid multiplying both equations by a number. Sometimes you're going to have to, okay? But you want to try to avoid that. So if you look at this, if you look at your y's, the y on the top is, the coefficient is 1, the y on the bottom is 2. If I were to take and multiply by a negative 2, so multiply everything in there by a negative 2, leaving the other one alone, now if I add those, the y's go away. I have negative x equals negative 9, divide by a negative 1. So I have 9 being my x-coordinate. I have to plug back into one of the two equations to get my y-coordinate. I'm going to pick the top one again, just because the y in that one, the coefficient is the coefficient is 1. Sorry, I got distracted by the math I was doing. So I subtract 18 from both sides. I was thinking about the 18 that I was subtracting, and I wrote that as a 23. Okay. So that's what we have for that one. Okay, now this one is the most complicated one that you're going to have. So I'm going to rewrite the problem. I'm going to rewrite the problem kind of in the middle. I'm going to just rewrite it a little bit over because I don't feel like I have enough room to really show you guys what I want to do. Okay, so for this one, you want to get your coefficients again so that they are the same value, just opposite signs. So if you look at the 4 and the 3 here, the 4 and the 3, they're not opposite signs. But if you look at this 3 and the negative 5, they're opposite signs. So you want to eliminate the y value. So you have to think, what do I have to multiply by to eliminate the y value? I need 3 and 5. I need their least common multiple. So if I multiply this equation, both sides, by 5, I'm going to get going to multiply that by 3, so I get 9x minus 15y equals, I didn't trust myself on 23 times 3, negative 69. So now add those two equations. So I get 29x, the y's go away, equals a negative 29. I now divide by my 29. X ends up being negative 1. So again, I have my x coordinate. I need to get my y. You pick one of the two equations, okay? The top one has only positives, so I'm going to pick the equation on the top. I add the 4 over. I divide by 3. So that is my video on solving system of equations by elimination. Thank you for watching.